Hello everyone, welcome to next Dockler Holding stream. Today we're going to talk about large-scale refactoring and basically how we converted tons and tons of unit tests from one language to another. As it is probably today happening to many companies, we had a huge code base in ActionScript 3 and we're porting everything to Hex. And we didn't want to rewrite everything from scratch, but there are tools that just go so far, and we wanted to convert the logic as well, not just syntax, but we wanted to convert unit tests to be able to eliminate manual labor. So first step, pretty classical one. Use AS3HX to convert the syntax, and it does pretty good job, but it's just syntax. We also wanted to convert as much as possible to basically switch between frameworks, because that thing would be also a repetitive task. We wanted to avoid that. So in a step 2, we would have to go through every single test case, adjust everything from one framework to another, and that thing could be done automatically. And we used Undebt for it. I'm going to talk about Undebt today mostly. And the step 3 is just obvious. We need to fix the business logic because the whole code base changed. But at least we have the asserts and we have all the mocking stuff done. So let's talk about Undebt. It is a tool developed in Yelp, where they needed basically to refactor and remove technical debt from a massive code base. I call it find and replace on steroids. It is very simple, easy to use. It's written in Python. Here are links to the official repository. It's open source under MIT license. I very recommend reading the introduction blog post because they talk about their motivation for writing this tool. And of course, here's a link to documentation. So you basically can read everything in the web pages, and there are couple of examples in the GitHub repository, but they're pretty simple and they don't really show exactly what is the power of Undebt. So first example, what we used is because AS3HX converts metadata to a special format, and we needed to clean it up for Hex. So basically everything consists of two things. There is a grammar which basically matches line by line or by multiple lines on supplied file, and then there is the replacement which is executed on each match. So this very simple logic does basically just takes everything, takes the add column meta, throws it away, throws left parenthesis, throws it away, keeps the name, right parenthesis, throws it away, and the new line, and that one is thrown away as well. And this thing basically just takes the name and puts it there. So the replacement goes from this complicated, not really readable, and not very usable compile time metadata to a runtime one. It also provides assertions. So currently this example is using tokens as list, which grabs whatever are the matches, puts them into list, and asserts length of them. So I know that this thing will always work, and if there is something that matches but provides more, it will throw exception. those lists are not very readable. So it also provides another one, tokens as dictionary, which I will show you next. In this example, we wanted to convert data providers, so for unit tests. So for the old syntax is this one, which basically you can see, and we needed to convert it to hex unit syntax, which uses composition of the metadata tags. So again, this grammar basically is using the dictionaries, where we grab an indent to be able to indent properly the beginning of the string. Then there are keywords, the at test, which we want to keep, so we name it. The indent is named as well. Left parenthesis, then keyword data provider, which we don't need, so that thing will be thrown away. Equals, and everything that is not named will be thrown away. Then we have some name string, and basically closing, what's this? Closing quotes and right parenthesis. So the following return basically takes the name of the data provider and puts it here, and we grab the indent as well, so we properly indent the second line. Otherwise, it would start on the beginning of the new line, and we would have to format it, which is annoying. So this thing automatically puts the correct indentation in there. Right. The next example is even more complicated. Usually the returns and the replaces are pretty simple, but the grammar is getting more complicated. Here we're using also optional parts. So the old syntax was using Mocha2. No, was using Mocholet, and we want to convert it to Mocha2. So Mocholet syntax, you define the mock, set a method, and what it returns. And because in Mocha2 the resulting syntax is identical to defining that there are no arguments specified for the call, we kept it in one single grammar, which is this optional part, where optionally the string can contain this thing, which will be then thrown away anyway because we don't need it. So this grammar again grabs the mock keyword, throws it away, left parenthesis, then what is being mocked, right parenthesis, dot, keyword method, again we don't need that one, left parenthesis, quotes, and then skip to, which basically grabs everything until what we specify, so until the next quote, which we call a method name, because we will need the method name. Then the quote until which one we are skipping, right parenthesis, dot, then the optional part with the no args, and then the keyword returns, which we need afterwards to basically grab the content of the parenthesis, and semicolon. That's pretty much it. So the resulting will be throwing away the mock stuff, just puts in the first place the thing that we found, dot the method that we found, and what it's supposed to return. Now, because it's a Python code, we can do multiple passes, and we can store data between those passes. So in this example, there are two parts. First part, we find all the mocks from the old mocklet syntax, where everything had to be annotated with the mock metadata, and it had to be public. With Mocha 2, it's no longer the case, because the mocks are initialized differently. So we can make everything private and throw away the mock metadata, which is this first step. Pretty simple grammar, and as a part of this step, we're also saving everything that we found, and we're gonna reuse it later. So yeah, this one finds everything annotated with mock, and makes it private, pretty much, and throws away the mock metadata. Now in the second step, we find the before function, which is annotated with before, and we don't really need the content of it. We don't need to parse it. We don't need to match it with anything. We just need the keyword before. Then we skip to left curly brace, which is where our basically definition of the function starts. Then we grab the left curly brace. We need the indentation because we're gonna use that. We skip to the right curly brace because that's the whole body. We don't need to modify it at all. And we grab the right curly brace. Now, because we have all the mocks stored from the step before, we can just one by one initialize them. So we need, in the before function, call this, whatever the mock is, equals mock and the type that we are actually mocking. So this thing takes, uses, basically puts all the mocks together on every single line, and then later on, when it is returning it, it puts it together, and before the body puts all the initializations. So we don't need to initialize everything manually. It's just it's just there. And yeah, that is pretty much it. Like those were really examples that we used. We of course used much more things, but most of them were just pretty much variations of what I just showed. Yeah, thank you.